you get to eat pie in town, and it's perfect. All right, there are a lot of other instruments at each one of these locations. There are a lot of other instruments. We have an interferometer in Socorro that I'm going to talk to you about that we're renovating. We have a long wavelength array, and we have an instrument called a V-Light, which is an ionosphere detector, and it runs commensally on our antennas, which means it just sits in the background and observes whatever we're observing, but in a different discipline, which is quite exciting. Of course, you're familiar with the 40-foot, the 20-meter, etc. here in Green Bank, but we always try to have other instruments and experiments. So let's talk about the organization, so you get a sense of where you are and who's working in the observatory. We are, let me go back one just to show you, we are actually funded predominantly by the National Science Foundation. We are managed by associated universities, and then we're operated by the NRAO. So these instruments aren't actually NSF puts a management company between us operating and the funding source. That way they can change management companies without doing anything to their facilities. Okay? And we just went through a major recompetition for ALMA and the VLA and associated CDL, those kinds of things. And we won a 10-year contract, which is very unusual. They usually give 5-year contracts. So that was good news. Some of you may have heard rumors of divestment for Green Bank and VLVA, and basically that is true. What NSF is trying to do is get other organizations to step up funding operations of Green Bank, the Green Bank facility, and the Very Long Baseline Array facility. And those attempts to get additional funding are going well. And so, but we don't know what in 2 years, what that will look like for those two facilities. Okay, so there is some ambiguity around what does that look like in 2 years. So one of the things that we proposed in that for the contract that we just won was that we would create a like environment for doing educational and public outreach at the Very Large Array, which is one of the reasons why we're investing in building up some instruments similar to the 40-foot and the 20-meter that people can use to learn about our instrumentation. So it's a brave new world. So going back over here, we have the AUI, Associated Universities Incorporated, President, Deacon Schreier. Our director is Tony Beasley. And within the NRAO organization, as it currently stands, we have the director's office, and one of the things I'm going to talk about is a program that I run in diversity and inclusion, and that's it through the director's office. I also run the program management department, and I oversee project management activities, program management, and systems engineering. Those are, every one of my staff, including myself, is INCOSE certified, which is an international standard certification for systems engineering. And in addition, we're PMI, or Project Management Institute, certified in project management. So we run that program. We also have your ALMA North America operations, your West Virginia operations, including the Green Bank and the GBT and the 40-foot and the 20-meter, all of those instruments. New Mexico operations, which is the VLA and those associated facilities. The CDL, our science support and research, data management and software, and education and public outreach. So I'm going to spend a lot of time talking about education and public outreach and diversity and inclusion. So as far as our instrumentation, you have the standards, the front ends, the back ends, the correlator, your typical. We also do research and development at this Central Development Lab, which is in Charlottesville. And we do R&D in areas of millimeter and submillimeter detectors, optics and electromagnetic components, low noise amplifiers and optics, digital signal processing, integrated receivers, and phased array feeds. Anybody been to the CDL? Yes, okay, good. If you ever want to visit the CDL, let me know and we'll arrange it. All right, let's talk about the fun things. I wasn't sure whether you knew the sort of the breadth of topics that we study. So I thought it might be interesting if you could see some of the science categories, like cosmology, galaxy formation, precision astrometry, such as the galaxy spiral structure and dynamics, detection of gravitational waves, extrasolar planets, astrochemistry, astrobiology, solar systems, including space weather, ionospheric physics, detection of near-Earth asteroids. We all know those are, it's important to find those before they hit us. Continuum sky surveys, time domain work such as fast radio bursts. Anybody heard of fast radio bursts? In the news a lot lately. And then cosmic reionization, epoch of reionization, earliest galaxy, earliest universe type of stuff. And then Breakthrough Listen. Breakthrough Listen is an initiative here at Green Bank to, it's sort of SETI work, search for extraterrestrial signals and that type of thing. And there are others, but these are sort of the predominant ones. All right, so let's talk about our instrumentation. Many times we use more than one of our instruments to do various types of science, so we get different results. In this case, we used the VLA and ALMA, and we were looking at planet formation. And HL Tau is a typical protoplanetary disk around a solar mass star. And what ALMA was used to do was sort of get down to the details of what was going on around this star formation, and then they used the VLA to take it down one more into fidelity, and then you get what you get is this view of what their hypothesis. Well, there's more than one, but one is that there's a the dark part is where a planet is forming, and then another theory is that the light part is what's like the dark part is a planet is carving around here, and then another theory is that the matter is being drawn into a planet that's forming. So it's pretty interesting what you can get with those two instruments together. ALMA has also measured the mass of a supermassive black hole, which is pretty exciting. And really these results right here that you're looking at in the bottom really demonstrate ALMA's ability to determine the mass of these black holes by resolving the gas kinematics on small scales in the galaxy nucleus. And then the VLA has performed studies in the origin of stellar multiplicity, so multiple star systems. Anybody like those? Like, is that a field that you're interested in? Multiple star systems? Okay. And then the VLBA has determined that there is a pulsar in orbit around Sagittae. So this is pretty exciting. And you know, they're really looking at the velocity and the position. And that's consistent with the bound orbit, originating in a clockwise disk of massive stars orbiting Sagittae. And then VLBA has also imaged an H1 cloud at redshift of 0.123, and this is also, you know, some really good results that you can see on the right hand side here. GBT discovers fast radio bursts, and this was an interesting story because the first fast radio burst was detected, I believe, in the UK. I'm not sure whether it's a Jabra Bank or not. I think it was. But they determined after some validation that that was not really a fast radio burst of interest. It was really caused by a microwave lunch. So, but we went and did some backup work, and we tried to observe additional fast radio bursts so that we could confirm that there was such a thing. And we believe that we actually have determined that there is, and that we've identified one in the H1 21 centimeter line. We did that through that intensity mapping project. And then, I think this is my last one on science, the cosmic bulk flows in the local universe is also a GBT project. It's part of the 2-mass Tully-Fisher survey. And they're looking at velocity fields within 100 milliparsecs with an all-sky coverage, and pretty fascinating study. They're looking at space and red redshift distribution of galaxies, which is an area that I absolutely love. This is one of the areas that I focus on. Oh, one more, as showing the combination of GBT and the VLA, and that's dark filaments and massive star formation. And these are the infrared dark clouds that are harboring the earliest phases of massive star formation. Pretty cool images. All right, so now we can kind of shift gears and talk about education and public outreach and how we interface. I thought it might be useful to give you a snapshot of all of the education, all of the outreach programs that we currently do. And they're by sites. We have Chile, we have VLA, Socorro in general, Green Bank, CDL, and Edgemont Road. And then along the bottom axis is K-12, undergraduate, graduate, postdoctoral, and professional. And so you'll see the 9 program there, and there's also a NAC program, which is this one right here. And I'm going to talk about those 2 programs, but the 9 program is my program. I'm the project leader on that program. And that is our only international program. It's our only multidiscipline program. So I'm not only looking at educating scientists, I'm educating engineers, technicians, and others that support the operations and maintenance and use of radio telescopes. So this is, I'm going to spend some time, and I educate professionals, anybody who has a master's degree or on in that program. So they don't have to be in school, they don't have to be a student, and we call it a professional program. So in our STEM, in our education and public outreach programs, we have teacher STEM training, science, technology, engineering, math. And you may be familiar with Skynet. We talked about that a little bit earlier, Skynet Junior Scholars, which you can access the Skynet network to get onto the 20 meter. We have radio astronomy ambassadors. We've trained 60 undergrads in this program and engaged over 10,000 students in West Virginia and engaged over 11,000 students in Chile. I've tried to put some interesting pictures of things that go on so that you can get a sense of where we're going with this. We also have authentic student research training programs. Pulsar Search Collaboratory, you may be familiar with. Skynet Junior Scholars again. We've trained over 5,000 US students. And kids have actually discovered 7 pulsars and 1 rotating radio transient. So that's pretty cool. We have summer camps. Ping is one of our major projects. It's brought 40 rising underserved 8th graders to Green Bank, and they actually had a White House event that they went to. And we have astronomy role models. We do science fair mentoring, judging, science club connections. We've reached over 2,000 US students. And then we host and attend events such as open houses, science days, first Saturday tours at our facilities, Enchanted Sky star parties, and Star Quest. We've had over 22,000 event visitors to NRAO on those. And then our visitor center, over 46,000 tourists to Green Bank, over 21,000 to VLA this year. So we also have a public website. Our site has over 700 images and videos. So if you like the pretty pictures that I've been showing, please go to the website and feel free to draw some of those down. We have 400 news items, 49 articles, and a lot of STEM activity reaches, estimating around 1,500 visitors every day. We have social media as well. So Facebook, anybody? Anybody do Facebook? If you do Facebook, we actually have an NRAO page. We also have a 9 page, which I'm going to show you. And I think our primary social media uses are both the Facebook and the Twitter. Those are the 2 that we use predominantly. Citizen science. Of course, we support and encourage amateur astronomy and amateur radio astronomy, in particular, Society for of course, SARA and Radio Jove, plus others. And that's a good relationship. So what I would like to see in the next 5 years is, I know, when we're talking about radio astronomy growth, in the United States versus other countries. If you go to Chile, the population of individuals that are wanting to get into radio astronomy, they're early career, and they're excited about radio astronomy. And you see a lot of early career individuals trying to get into ALMA and other observatories down there. When you go to other countries like Africa, when you go to the UK, you see just an immense amount of interest in radio astronomy. You can go to many other countries in Europe and any of the other continents, and you can find an early career population that is passionate about radio astronomy. Now, it's complicated to get people interested in amateur radio astronomy, I feel, because there's not a lot of ways that they can reach in and touch this right away and get a feel for how do you do this. It's not easy, right? So one of the things I'm going to ask for is mentors, people that are willing to help early career people understand how to get into this field and be passionate about it if they're not in that field in a career. So I feel like we have to drive in a way to try to bring more early career individuals with a passion into SARA. And I'd like to see, within 5 years, the other half of the seats that aren't filled here right now with women and early career professionals that want to be passionate about radio astronomy as a hobby. So I would like to see that, and that's one of my goals. So we also have interactives and video production, so we're trying to reach out to that community that might be interested to try to pull them in a little bit tighter. We have a Milky Way Explorer, which has our telescopes that explain how they're used and how we explore the invisible universe with our telescopes. We also have a role model series. If you go on NRAO website, you can actually watch a video of everybody, whoever. There's just so many videos where people tell their own story about how did they get involved and find themselves in radio astronomy. And we have just now built and are getting ready to flow out this Radio Sky mobile app, which is a touch screen tour of radio sources and NRAO telescopes, and it also gives instructions on how to build your own itty-bitty radio telescope. So we're trying hard in various areas to bring in interested amateurs. So we also publicize our news and events. We put out a lot of publications in various ways. And now I want to talk about the diversity and inclusion programs. So we have two programs that I'm predominantly involved in. One is the National Astronomy Consortium, and this is literally a consortium made up of universities across the United States. And they pick underrepresented universities typically. They pick a group to come in the summertime and learn about, they do data reduction, they learn about different science projects, and they're involved in all aspects. It's not only at NRAO, but it's at these other universities as well. So I typically have one or two NAC students that come in and work with me, but in instrumentation. So I teach them how to use methodical methods such as project management and systems engineering to do radio astronomy kit builds such as the Radio Jove, and we work those processes all the way through so that they are observing with their Radio Joves or other instruments that we might build, and then they can learn from that experience. So that's pretty exciting. Adria was one of mine as well, and some of you might have met Linnea Sabi last year. She was here at the SARA conference, and she is now my lead. So when they come through the program, they can come back and take a leadership role in a feature session. NAC is a good program. I really enjoy it. My program is called the 9. It is the National and International Non-Traditional Exchange Program. Again, it's NRAO's only international program where we bring in international participants. And it's really designed to teach what I call sustainable skills throughout the full spectrum of activities that support radio astronomy activities. not only from the builds all the way through the observations, to teach those skills, and then to provide a way for those individuals that come and learn this, these activities, to go back and teach their own country, the people in their own country, how to do this. So it enhances the it enhances their ability to actually be able to generate more interest around the world in radio astronomy, and that's important to us. We feel that that's a really important goal. They also help us set up what we call hubs so that we can do exchange programs between professionals. So it's very easy for science staff to say, well, I'm going to go work in Effelsberg, or I'm going to work in South Africa, I'm going to work with the radio astronomy communities. Not so much so the people that are doing the engineering, instrumentation, or the technical work. So this is their opportunity to go to transfer between various organizations that support radio astronomy for short periods of time to learn and to help. So I'd like to introduce Rosalind Daka. She's one of my 9 professionals. She's here, and she just finished building her radio joke kit and doing her first observations a couple of days before we came out here. So happy to have her. She's from SKA, if you've heard the Square Kilometer Array program, down in South Africa. So she's from South Africa, Johannesburg. And she's now going to be a certified trainer, so she's going to go back and train others on how to do radio astronomy. Very cool. Okay, so our primary objectives of this project are basically to provide supported short programs, 9 weeks long, which was ironic because we didn't mean it to be 9 weeks. It just turned out to be 9. So, kind of a synergy there. And to position that participant to go back and train, and also to set up a hub so that we can interchange. And then what we're really interested in is this worldwide exchange of radio astronomy knowledge and the generation of early career, and a very diverse set of capabilities coming up in the world. So the NAC and the 9, under my program, we do service projects in addition to our learning. So I require everybody to do a project, to do a project, and we've done some interesting projects. We have done a technical manual and documented the VLBA Roche digital backend, and that had not been done, and that was a great project, and we were able to contribute our time to do that, and that was useful. We also did an as-built, as-maintained documentation project on the 40-foot. So we've digitally scanned all of the documents, and we went in and looked at what the way that the instrument was actually built, and then all the changes that had occurred up until last year. It was a very fascinating project, and we turned all those documents and everything over to EPO. We did a radio joke RFI characterization study here at Green Bank in the lab. So if you are interested in those results, I'm happy to give you the white paper on that. It was fascinating. Bottom line was, hey, you can observe with your radio joke during the daytime without any special shielding, but if you're going to observe at night, we have some issues. So we need to work on those. We also are working on at the Edscorn Observatory, which is in Socorro, behind on the New Mexico Tech campus, but behind the Dominici Science Center. Like a 5-minute drive around the golf course, and there you are at this observatory. And we have there 2 things. We have a 2-dish interferometer currently that it was in a very bad state. There was hail damage, it was not working, we had some pointing accuracy issues, and it was really very run down for about the last 8 years. It has not been cared for. So we took that on as a project, and we are painting, and we are going to renovate the entire building. We're painting inside and outside. We've bought new furniture. We've done everything that we need to do there. We've got a nice setup going. We have a lot of work left to do in the next 3 weeks, but we're going to have that ready for students in 3 weeks to come and observe. And that requires us to renovate Thank you. So we have to renovate these dishes, which means we are going to be replacing the mesh panels. We're going to be painting. We're going to be greasing. We're setting up. We're developing a maintenance manual so that we know how often we have to come out here and take care of these dishes. We're going to align them correctly and do pointing accuracy tests. We're going to make sure that the software is working, and then we're doing one more thing, which is really cool. We're adding a third dish. We're adding a third dish on the same east-west baseline. It will be ready by, hopefully, we'll have all the parts purchased by the end of the 3 weeks, and it'll take us about 6 months to get that third dish up and running and online. Now, and we're running these as sub-arrays, so you should be able to observe with a single dish, 2-dish interferometer, or 3-dish interferometer by the time we're done. So by the time you guys come out in March, you should be able to do observations, just like you do with the 40-foot. You should be able to do them with the 2-dish interferometer, at a minimum, the 2-dish. So we're writing up experiments, we're cleaning it all up, and this is our service project. We're very excited about it. Okay, so here's your opportunity to volunteer, because I know you've been waiting for this. So what I need are people like yourselves that are enthusiasts, that are knowledgeable about not just the science, but about the technical aspects, the engineering aspects. And we're doing these, oh, I meant to tell you that the other thing we're doing is we have an antenna range now. So basically we have set up two dipoles in a permanent configuration. So we're going to leave them there. We have them pretty well tightened down, where you can bring your Jobe and plug right on in there. We also have a Jobe. If you don't have one and you want to mess around with one, you're going to have access to the radio Jobe and the computer and the ability to do observations. We'll also have a user manual for each of the instruments, and so a maintenance package for each one of them. So we do have an antenna range. You can also bring your own antennas. Bring your own antennas and your instrumentation and give it a try, because this is our antenna range in New Mexico. So I'm looking for mentors. I'm looking for docents, people that say, I'm in the area and I'm happy to walk people through and explain what all of this is at ESPOR. I'm looking for people that say, you know, I'm happy when I come through there to do your maintenance for you. You know, grease the gears and make sure that the panels, replace the panels if needed. I'm also, I mean, my staff can do that. My staff will do that through the program management department. We will take responsibility of maintaining this thing. But if you want to participate, we're happy to have that participation. We also would love to have some engineers and software developers, because we're going to be building this third dish. There are no kits available anymore, and we're building it from the ground up. And I'll tell you, I've not built an antenna of this size, 10 foot, from the ground up before. So I would love to have some of your expertise brought to bear in this. We also need artists, because you know what, we're going to be painting murals on the outside of our building, and we're going to make it pretty special. And I would love to have some experiment developers, you know, for the interferometer. You know, what can you do with a single dish? How would you like students of all various ages to come in here, and what experiments can they do with the single dish or 2-dish or 3-dish? So there's opportunities if you are interested in helping in these projects, which I just consider service projects. Nobody's really funding us to do this. This is what I do as a passion project. You can email me, and I'm happy to take your request to volunteer. So our bottom line on this is that in partnership with the scientific community, the NRAO helps train the next generation of scientists and engineers, and basically promotes astronomy to foster a scientifically literate society. And from my perspective and my goals, I want to see the next generation, and both women and men, passionate about radio astronomy and amateur radio astronomy. So that's all I have. Hopefully you enjoyed that. Questions? Any volunteers?
What frequency is your 3-dish or to be 3-dish interferometer?
L-band. It's going to be L-band. It is L-band right now.
Okay, so 1.42 plus or minus?
Yeah. And we have some work to do. It is a equatorial, it's a, you know, it's a scan, you just use it to scan, you point it and let, you know, we're not pointing at something and tracking. We don't have that ability. We won't have that ability. But you can do drift scans, you can point, make sure that you're pointed in the proper place, and you can observe all different kinds of phenomenon, but in a drift scan mode. And same with, typically with the jellyfish. Yes?
There's documentation on all that hardware
The 2-dish?
available on the web or something? Yeah,
Not on the web. We have documentation to some level. When we're building, we actually ask the subject matter experts in our engineering department to help us to make sure that we spec this out correctly and help us get to further specifications, because there's not that level of detail. What actually happened is the 2-dish was a kit that we bought from Haystack, and that is no longer made anymore.
Right.
So we're having to build it from the ground up, component parts. And the other complexity is that the 3rd dish is double the baseline out, but it is lower down, and we're going to bring it up to an even plane so that we don't have to do that additional map. So there's some complexity about doing that as well. And yeah, we'd love to have some help on that.
Okay,
We
so
have
it
the
is
expertise, but
the Haystack
yes.
kit. Okay.
But if you go and you try to find specifications of this particular one, they're not there.
Oh,
They're not there.
Oh.
Yeah, so we've been recreating everything. Yeah, but that won't happen again because my team's involved, which means everything's going to be documented and that will all be available.
Okay.
Yeah, for future generations. Any other? Yes.
Well, as far as volunteers, is it useful to have volunteers, let's say a week, that someone could come down on their vacation time or something like that?
Even if it's just I can't come down there, but I'm willing to mentor somebody via, you know, telephone or Skype or something. If you have somebody who's struggling with how to set up experiments or how to do an education program or whatever, I would love to have that list, that stakeholder list of people that will help us. And I can say, hey, here's a list of people you can call, you know, that are willing to have a conversation with you about how you're doing this. But yeah, if you want to come out and, you know, spend a week of your vacation playing with the dish and helping us align it and doing, you know, doing some maintenance on it, fantastic, fantastic. And helping as kids, as groups come through, explaining what the 2-dish or 3-dish does, and yeah, fabulous. That would be awesome. Yes?
Do you have to go into basics with the students? I mean, what radio is and the whole, do you have to start from ground zero, or what kind of a background do they have?
Well, I would ask the same question for the 40-foot. So we're creating a program that is very comparable to the 40-foot. So typically when we bring students in for that instrument, we give them basics, sort of in an introductory session. Here's what it is, and here's how you use it, and then we pop them out there and let them experiment, right? It's an experimental kind of exercise for them. They learn by doing. And we're trying to incorporate some of that same learning methodology into what we're doing. So we want them to be able to do things without breaking something fundamentally. So we want them to be able to get hands-on and understand what they're doing, but there will, and this is why I say design of experiments is really important to us, because we want from the middle school age, actually, you know, any elementary school age, because there are things that they can look at and do, and pointing the telescope, all the way through a doctorate level person who wants to come out and do hand calculations on how to reduce data from a 3-dish interferometer. I mean, there's lots of experiments that can be done. We have a small subset of experiments designed right now, and we need a lot more design. So from all school ages. So you have to have a package of experiments for an elementary age kid, and you have to have all the way up to a series of experiments for somebody who is a doctoral candidate or has their PhD already. Yeah.
Last week at StarQuest, we built 6 IBTs, and I've given 5 to Camera Concepts, and we're looking at having a commercial venture for IBTs. There's a lot of interest in people building them. With that, I'm going to update the documentation, so you're more than welcome to have that.
Great. You want to put one at the ETSCORN? You want to put one at ETSCORN? if you put one at ETSCOR, and then we also have that instrument that people can look at and play with, that'd be great. Yes?
What is the status of the solar spectrometer, radiated solar spectrometer, right next to the gate?
I don't know
The
that I know the answer.
telescope next to the gate.
Yeah, I don't know I know the answer to that, but I can find out for you. I will find out for you. Yeah, I don't know, I'm sorry. Any other questions? Okay, thank you so much. Appreciate it.